Year 10. So, last lesson, we got to this section where we were going to look at how earthquake waves are used to give us this idea of the structure, or the internal structure of the Earth. Essentially, earthquake waves work a lot like ultrasound. Okay, so I asked the question, how could we possibly know the structure of the Earth is layered like this? um, Given that we've only ever drilled about 20 kilometers, so about 1/10 of the way through the Earth's crust. Okay, so what we're going to do today is I've got two videos to one. One is about 20 minutes long, and the other is about 5 minutes long. Slight glitch with these, so I can't put them in the usual links. Um, so what I will do is I'll try to upload them to files and assignments, so you can hopefully get them from there. If not, I will also upload them into Show My Homework for you. So first thing you need to do is you need to pause this tape and watch the two videos, which are in assignments, files, but also will be in Show My Homework. I would like you to make a few notes on those. Particular things to look out for are, what are P waves and what are S waves? What are the significant differences between the two? And how do they give us the structure of the Earth? Now, once you've watched the video, I will be going through this in quite a lot of detail. So you might want to leave some space to add to your notes. Okay, right, so pause the video and do that now, please. Okay, Year 10, welcome back. So hopefully you've got an idea now of what P waves and S waves actually are, and how earthquakes happen, and how we can use the waves produced. The first thing I think I would like you to do is is make a copy of this little table in your book. Make sure you leave plenty of space, because what we're going to do, we're going to draw a diagram in a moment about how we know this. We're going to draw sort of upgraded version of this essentially. Okay, so actually, P waves are longitudinal, which means they are compression waves. They travel faster and can travel through both solids and liquids. Okay, S waves, so secondary waves, are transverse, they're slower, and they can only travel through solids. Okay, now that fact, we know that longitudinal waves go through solids and liquids, so we know they can, but we've always known that transverse waves can't travel through liquids, okay, actually physically through them. All right, and that's an important thing to remember. But what I would like you to do is I would like you to draw up a diagram like this. In fact, actually, though, you don't need those labels. I'm going to presume that you already know that they are here. Oh, actually, I might just leave on this part. Bear with me a moment. Okay, so I just made a few little alterations. So you probably do need actually the mantle, which is solid, the outer core, which is liquid, and the inner core, which is solid again. You might wonder why that happens, because you might think, well, hang on a minute, if that's hot, that's hotter, and that's the hottest still. If that's melted to liquid, why is that solid? Well, the reason for that is because the pressure, the weight of the mass above it pushing inwards, has basically, although this, yes, it's so hot that it's melted, here, although it's absolutely super hot, it's all been compressed. It's like putting a snowball and squeezing it so hard you essentially squeeze it back to a solid ice. It's a bit like that. Anyway, what we're going to do today is we're going to see how we know the structure of the Earth is layered like this based on earthquake waves. And what we got, and what you are going to draw out as we go, is sort of a cut through of the Earth. You've got an earthquake epicenter here at the top, and then you've got 1, 2, 3, and 4. What these are, these would be earthquake monitoring stations. You can pick up earthquakes all over the world. Okay, vibrations and rocks travel all the way through, all the way around the Earth. But how we use these earthquakes to actually determine the internal structure of the Earth. So hopefully the videos have given you an idea. Now, we're actually going to start with the secondary waves, because those are actually slightly easier to explain, the S waves. Now, those are transverse waves, and I hope you remember the golden rule of transverse waves is they cannot go through liquids. Okay, really important. They can't travel through liquids. So, outer core is liquid. So, these S waves can travel through the mantle easily, and they can travel through. They could travel through the inner core, but of course they wouldn't get there because the outer core is a liquid. Other little things, if you just remember, the waves are slower, so they would basically turn up second. Okay, they turn up afterwards. Right. Let's think about this. The S waves travel outwards from the epicenter. Okay, so I'm just going to choose a color, do these in blue, for example. And what they do is they travel outwards like that in all directions. And what you get is this. Now, I've done that really badly. Just bear with me a moment. I'm going to redraw that slightly. I might actually use straight lines. These wouldn't actually be straight lines, but just for simplicity, I'm just going to do that. Right. So they can travel through the mantle easily enough, these secondary waves, because they can travel through solid. However, what happens is when they get to here, the outer core, bear in mind, they can't at all. So what you've got is this. You've got these secondary waves, and as you can see, eventually, they will arrive at your stations. Okay, so they would arrive second after the primary waves. The first thing we know is that they are slower than the primary waves. What is interesting, what it gives us, secondary waves, we pick them up at Earthquake Station 1 and Earthquake Station 2. We don't get them at 3 and 4. And the reason for this is they don't travel through liquids. Okay, what we actually get, there are actually earthquake stations all over the Earth. And the X waves will travel to about there and then stop. And the simple reason for that is they can't get through this layer. And only way we know to explain that is, well, we know the transverse waves, and we know that transverse waves can't travel through liquid. What we actually end up with is what we call a shadow zone. Okay, so I'm just going to type that in there. So you might want to add this to your diagram. Shadow zone. And this is where we get absolutely no S waves. Okay, so let's think about the conclusions we would draw from that. We can pick up S waves, so secondary waves, about halfway around the world. And then all of a sudden, like that, stop. Something is blocking them from this area here. And the only way we know to explain that, the only logical structure that makes sense, that part of the core is liquid. And S waves, being transverse, could not travel through liquid, therefore they're not protected here. So we get this shadow zone. All right. So what I would like you to do is think about the logical conclusion. The only conclusion, therefore, is that part of the core is liquid. Okay. So that is the conclusion the S waves give us. We know that the mantle must be solid because the S waves travel through that. Okay. They must hit a liquid layer because they can't travel through that. That is the logical conclusion based on these findings. Okay, so what I'd like to do is draw that. Okay, I would suggest you use a color like I've done here, like blue. Okay, because you're going to use another color to represent the P waves in just a moment, or you might even want to do it on a separate diagram. Okay, so pause the video, draw this, make sure you include the shadow zone, and explain how. Okay, we know that part of the core is liquid. Okay, so think about transverse waves, think about the properties of transverse waves. Okay, pause the video and do that now, please. Okay, welcome back, Year 10. So, just going to have a look at P waves now, primary waves. Now, these are longitudinal, and these spread out in much the same way as the secondary waves. Okay, see these ones in green, so you can sort of clearly see them. So, these spread out from the epicenter of the earthquake, and once again, they would spread to all parts because they can travel through solids, don't forget, but they can also travel through liquids because these are longitudinal waves. So firstly, we would get to these earthquake receptors first. Okay. Now, really interesting thing they've told us is what happens when they meet a boundary, when they meet something which is a different density. Now, obviously, solids and liquids, this is solid, this is liquid, this is solid again, have different densities. So, when these P waves enter the outer core, which is a liquid, they will refract slightly, like that. These ones are going in straight, so I'll just draw those ones straight. And then these ones will refract slightly again. But what the seismometers notice is when they got to the the inner core, refracted again. And then what they do is they get to liquid, they refract again, like that. And then obviously they'd refract one more time when they left the outer core to get through the mantle. Okay. Now we can time exactly how long it takes for earthquake waves to get us. So what you get as you go through the core is this refraction of waves. And sophisticated computer models allowed us to work out that basically refracting, P waves were refracting as they went from a solid mantle into a liquid, which is a different density, back to a solid. Now, it worked out this was refracting again at a certain level. That means the inner core must be solid. And the only way scientists knew to explain this was that the iron and nickel, which we find mostly in the core, must have been compressed so much by the weight of the rocks pushing down on it. It was basically compressed into a solid. And so therefore the waves would refract again at that boundary, they refract as they leave, go to the liquid, and then of course they'd refract again as they leave the outer core into the mantle, because that's a liquid and that's a solid. So by mapping this refraction, we're able to sort of map layers of the Earth. Okay, what I'd like you to do is add this diagram with an explanation. So you're going to need 2-3 sentences to explain how the refraction of the P waves, the primary waves, through the Earth's core gave us this model. Now remember, waves, these waves can travel through solids and liquids, refract when they meet the boundaries of different densities, and this refraction can be picked up by seismometers all over the world because refractions cause ever so slight delays in when those sound or seismic waves arrive at the detectors. Okay, and from that, sophisticated computers were able to model this layered structure of the Earth, and this is how we know the Earth is like this. In essence, we needed we basically have done a giant ultrasound on the Earth. That's how we know what the structure is. So much like we use an ultrasound to do a prenatal scan on a baby, we've done essentially an ultrasound on the Earth. The only difference is we're using much more powerful waves created by earthquakes in order to give us that information. Okay? Right. So, having watched the videos, it should take you about 25 minutes to get through, and obviously watching this is about 15 minutes. Okay, that's pretty much your 45 minutes up. So by the time you've done your drawings, that pretty much be the lesson. Next week, what we are going to do is we're going to do a bit of a finish up on ultrasounds and just review, make sure we know that. and how they work before we move on to electromagnetic waves. Just a couple of things for you. Next week, on Tuesday, I will be the duty member of staff in school. So if possible, I won't be online to answer the lesson questions. Okay, so the lesson will probably just be some set work, which I set you. Log in, register as normal, please. But I'll try and make myself available because I'll be on a computer, but I might be dealing with other situations as well. So understand that I might not be available for the whole lesson next Tuesday. Wednesday will be a normal lesson, and also I don't see you on Friday. Okay, and then obviously some of you will start coming back in the following week, and hopefully within a few weeks I will be looking forward to actually seeing some of you. So hope that all makes sense. I will be online this afternoon to go through the questions, especially for this section if you need it. But other than that, just make sure you've got this diagram for both P waves and S waves with 3 sentences explaining in each case how we use P waves, how we use S waves, how the properties of the P waves and S waves allow us to determine the internal structure of the Earth. Okay, thanks guys, see you in a bit.